CO2 obviously is not made, but maintained in the lungs, right? Funny looking lungs, but there they are. Okay? That make sense?
Yeah.
So far?
Yeah.
Okay. So right offhand, we already know that we're gonna have some things that are respiratory controlled, right? And we know we're gonna have some things that are metabolically controlled. That make sense?
Yeah.
Okay. Now, when we're talking about acids versus bases, one thing you need to, again, remember, another thing you need to remember is bicarbonate is a base, okay? They call it a buffer because it'll actually balance out acids in the body, okay, but it's a base. CO2, we actually say it's an acid, even though CO2 is probably not an acid, it's a gas. But the reason we can say that is because if you take CO2 and you blow it out of your lungs, right? What you're doing is you're shifting this entire equation that way. If you shift that entire equation that way, what you're doing is, again, keep in mind that, you know, this is all about the acids and bases in the bloodstream, right? So that's your artery or your blood, right? If you shift the entire equation to the left here, what you're doing is you're taking this hydrogen, which is acid for real, right? And you're shifting it this way and actually blowing it out by default, by getting rid of that CO2 out of the system. Does that make sense?
Yeah.
Okay, so you get that acid out of the system, so it makes it easy for us to say CO2 is acid, bicarbonate is base. Okay? So where this comes into play is, of course, when you are talking about acid bases in the blood, first thing you need to know is, unless otherwise stated, when we're talking about acid bases, we're actually talking about our arteries, not veins. Okay? We're literally sticking a needle in an artery and sucking up the blood out of the artery, arterial blood gases they call it, okay? Or ABGs, arterial blood gases, okay? So, if you are taking the blood out of the artery, what you're doing is you're gonna have some problems. Again, in your PowerPoints, it's gonna mention a whole lot of reasons why you can have metabolic and respiratory acid states and alkalotic states, okay? But really what we care about is what's going on in this blood at each of those instances, okay? So if you have, for example, respiratory acidosis, okay? What that means is if you are looking in the blood itself, you're gonna have an acidosis state, okay? Otherwise you wouldn't say you had respiratory acidosis, right? Well, right now the respiratory part is irrelevant. We know that you have acid in the blood, which means that your pH is going to be low, okay? All right, and again, normal pH, by the way,
7.45 or something.
okay, 7.35 to 7.45 is normal pH, okay? Yes?
Mm-hmm.
So if you have low pH, below those levels, we say you have acidosis. If you have pH above those levels, you say you have alkalosis, right? Does that make sense? In other words, alkalosis, you have basic blood, and acidosis, obviously, you have acidic blood. Okay? Now, keep in mind that either one of these states, whether it is acidosis or alkalosis, they can be caused either by a problem, and it's kind of important, respiratory or metabolic acidosis, the way you're defining whether or not it is respiratory or metabolic is who's causing the problem. Okay? Who's causing the problem is really the key. Does that make sense?
Yeah.
Mm-hmm. And this
Okay.
is like either a hormone or,
Huh?
does this relate into, is the problem the hormone or?
No, it has nothing to do with hormones at this point. It's literally who's causing the problem. Okay, so for example, let me say, let me give you, again, keep that in mind, that whole picture right there, but let me give you an example down here and say, okay, we have a problem in our blood, and we have our blood that has a pH of 7.28, whatever, okay?
Oh, acidosis.
Okay, so automatically we know what? That is
Acidosis.
acidosis, okay?
Respiratory acidosis, right?
No, we don't know anything yet.
Oh, okay.
All we know is acidosis, okay? So we have to figure out what the problem is, okay? So we're gonna get some numbers when we stick that needle in that artery.
Okay.
One of those numbers is our pH. Another number that it's going to give us is our CO2 level, and another number it's gonna give us is our bicarb level, okay? All right, so like I said, that can go either way. Say, for example, I make your CO2 level, 30, right? And I make your bicarb level 8, okay? Now, obviously, what we have to know is what our normal CO2 levels are and our normal bicarb levels, don't we? Okay?
Yeah.
Our normal bicarb levels are going to be, again, it really depends on the lab you're using, but I believe in the back of your pathophysiology book, the Bio 43, it says normal is it 22? It might be 22. I thought it was 24 or 28 in your book. Okay, fine, let's go with 22, okay? Again, it doesn't matter to me because these numbers are very subjective as far as being exact, okay? Again, it really depends on the lab and some other factors. Okay, so that's normal, we'll say, okay? Notice the number I made this is way out of normal, yes?
Yeah.
Okay. Your CO2 normal levels